Alright, welcome back to another Java tutorial video here. Just readjusting my headphones. In this video, we're given the problem of recursive tracing. Now, what recursive tracing does is a method will call itself within itself. It's kind of like an inception thing, but it will eventually return a value from the base case. Now, what we're looking at here is this method. Usually the base case comes first, but in this case it's just a test to see as to whether or not the value of integer n is negative. If it is negative, then what we're going to do is we're going to go back through our mystery. We're going to make it so that n becomes positive, but when we get the end result of that, we're going to make sure that we get the negative of that ending result as to not get confused. This else if statement here just so happens to be our base case. Why? Because, as you can see, there's no recursive calling here. We do not call upon the method itself within this case. Now, in the else statement here, this is assuming that n is a positive number that is greater than 10, or at least 10. What we're going to do is we're going to call upon the mystery method of n divided by 10 itself. We're going to add n plus 1 modulus and then mod that by 10 at the very end, and then we're going to multiply that whole thing by 10. So let's dive into it. So I just copied the code into here. So we're given our first mystery call. In this case, n happens to be equivalent to n is equal to 7. So the way we go about this is we say, okay, n is equivalent to 7. Let's go through these cases here. Is n less than 0? No. So we move on to our next statement here. Is n less than 10? The answer is yes. So what we want to do is we want to then hit this return statement here. Now what we're going to do is we're going to say, hold on one second, n plus 1, which happens to be 7 plus 1, modulus 10. Now what this will do is this will equate to 8 modulus 10. And what ends up happening is when you when you mod something, you're seeing how many times this 10 goes into 8. It goes into it 0 times. So the remainder that we end up getting is just 8 by itself. So if we decide to say, okay, this is going to be A, we're calling mystery of 7, it will just return 8. Alright, well that was easy. Now we're going to move on to the second case here, a mystery of 42. So if I just put that in here, this is a little different. What is this going to be? So I should actually probably comment this out so that if I ever decide to compile any of these codes, I don't want to have that miscellaneous thing there. So in this case, n is equal to 42. So we're going through our casing here, and we say, okay, n equals 42. Is n less than 0? No, 42 is greater than 0, so we miss that. Else if, is n less than 10? No. So we fall upon our last case because we've missed those other two. And we know at this point n is equal to, well, let's just say this is our first run. N is equal to, first run implies that n is equal to 42. Alright, so what we're doing when we hit this mystery here is we're saying, okay, we're going to take 10 times the mystery value, and in this case, our mystery is going to be mystery of n divided by 10. 42 divided by 10 just leaves us with a 4 because of the mathematics of programming. It's not like 4 point blah blah blah. It's just a raw 4. So we're going to get 10 times this plus an additional n plus 1, which in this case just so happens to be 42 plus 1, which is 43, modulus 10, which just ends up becoming a 3, because when you, the remainder of 10 into 42, or 10 into 43 just so happens to be 3. So we return this. Now, this is the interesting part where we get into the recursive tracing here. You guys notice that we're returning something, but we're returning the mystery here. Now, this is where things get a little bit funky. Because what we can say is we're going to go through our mystery here. We're going to plug in the value of 4. We're going to test it. Is 4 less than 0? No, we pass here. Is 4 less than or equal to 10? Yes. We know that our second run here, implies that n is equal to 3. N is equal to 4. I did that right? Yeah, I did that right. So what we're doing is we're going to return the value here of n plus 1 modulus 10, which just becomes 5 modulus 10, which just equals 5, because the remainder is always going to be 5. So what this means is we go down to here, we've hit our base case, so we return this back into the mystery of 4 here. So we end up getting 10 times 5 plus 3. And this ends up becoming, well, you start with multiplication first because you don't forget PEMDAS. So we end up getting 50 plus 3 is 53. And lo and behold, that just so happens to be the answer there. Now, let's move on to our next case here. We're dealing with mystery of 385. Eventually it's going to get to a point where I'll actually have to start writing down pseudocode on paper. So what we're going to do is we say, okay, n is equal to 385. Now, do we hit this if statement? No. Do we hit the second else if statement? No. We don't. But we do hit this last one because it's greater than 10, thus being greater than 0 automatically. So our first run says that n is equal to 385. So what we're going to do is we're going to say 10 times the mystery of 385 divided by 10, which just becomes 38, plus n plus 1, which just so happens to be 385. Well, 385 plus 1 was 386. Mod that by 10, you're just going to be left with a 6. So that's what happens there. And so this is kind of interesting. We hit mystery of 38. So we know at this point we go back into our method. N becomes 38 now. It passes this statement and hits this last one. Now this seems a little funky because we've now breached upon this else statement twice. But don't worry, it should all become very self-intuitive later on. Well, we'll just get through this. So we get back into this method here. So we get 10 times mystery, and in this case our n is equal to, this is our second run. Our n is equivalent to 38. So we want to say 10 times the mystery of, in this case, n divided by 10, just so happens to be 3, plus n plus 1, which happens to be 39, modulus 10, leaves us with a 9. Now, that is what we're returning here. Now, as you see, we call upon mystery of 3, so we go back in the method, pass this statement, and we enter this. This happens to be our third run. and n is equivalent to 3 at this point. So what it means is we'll be returning 3 plus 1, which is 4, modulus 10, which gives us 4. So what we'll do is we'll return 4. So we go back to this case here, and we start from the bottom, and we go to the top. Just like that song, started from the bottom, now we're here. So 10 times the mystery of 4 plus 9, which ends up giving us 49. And then what we're saying here is because we get this, we go back on the stack and we go back to our first run. So we know that this mystery of 38 was originally this call here, which happened to be 49. So it ends up becoming 10 times 49 plus 6, which ends up becoming 496. And that also happens to be the answer to this question here. We can verify that by scrolling down here. Yeah, 496. Next should be minus 801. The next should be 90305. So we'll get back to here. So I will actually put the answers right here. Answer equal to 8. Answer equal to 53. Answer equal to 496. Yeah, because that's what it should be. Now we're making another mystery call here. In this case, mystery call of minus 790. So we're really hitting all cases here. We're finally hitting that negatives case. So what we're gonna say is it should be minus. At this point, we've entered our method. We're in the free zone here. We've embarked on a new planetarium. We don't know what's going on. It's a complete mystery here. So what are we going to do? So we've got this large number, but we've hit this thing here. So let's first start off with what we've always been doing. This is our first run. Our first run hits here, and at this point we know that n equals minus 790, and we've actually entered this loop, or this if statement, because n is less than 0 at this point. So that's what n is for our first run. And then what we want to do is we want to return the negative of the mystery of our negative number. So it means we're going to return a negative mystery calling of minus 790, which is just 790. So what happens is we go back in the recursive call, and at this point we know that n becomes 790. Now we pass by this, and we pass by this, and we get into this case here. This is our second run. And n just so happens to be equivalent to 790. Now, at this point, what we want to do is we want to say we're going to deal with this. 10 times our mystery call of 790 divided by 10 will just give us 79, plus 791 modulus 10, which is just 1. So what will happen is we'll go back in here, starting with 79 now. We'll loop through this, we'll find it, misses the if case, skips over the else if, and we go back here. This is our third run, and we know that n this time is equal to 79. So it means, once again, we're dealing with 10 times the mystery of 79 divided by 10, which just happens to be 7, plus, now this is an interesting case, n plus 1 modulus 10. That just becomes 80 modulus 10, and that leaves a remainder of 0, so we're adding nothing to that. Now what we're doing is we've hit this mystery 7, we're bringing it back in here, and we now start at this point here where n equals 7. So n equals 7, which is a positive number, so we skip over this, we get into the else case here. And at this point, we know that we are on our fourth run, and n is equal to 7. Now at this point, we want to return this value. So we want to say we're returning n plus 1 modulus 10, which happens to be just 8. So our mystery of 7 becomes 8. So what we do is we go back through here. We go from our 4th run to our 3rd run. Mystery of 7 just returned 8, so we're saying 8. 10 times 8, which just happens to be 80. Then, remember, this is our 3rd run. We call it into here. So mystery of 79, just so happens to be this. It's 80 plus 1. So this equals 10 times 80, 801. And then this happens to be our calling of mystery of 790, which will bring us up back here. So we want the negative of it, so it should bring us minus 801. So let's actually compare that to the actual answer. Scrolling down. And that leads us to minus 801. Okay. That's good. Now we have this big number here, 89,294. Let's run through that. Yeah, so E mystery of 89,294. Now this is greater than anything we've covered, but at least we're not dealing with a negative case, so we actually will never hit that if statement here. So we're dealing with this. So we've entered our loop. 89,294 is the number that's passed in. So we're going to skip over these first two things here. We're going to say, okay, our first run declares that n is equal to 89,294. And what we're going to do is we're going to say, okay, the mystery call on 89,294 just so happens to be returning this. So what we're going to do is we're going to say 10 times, sorry, a little dry throat here. 10 times the mystery of n divided by 10, which will just get rid of the last decimal. I mean, of the last digit in the one spot, so 888,929. So we're going to be looking at plus n plus 1, which gives us 89,295, modulus 10 is going to give us 5. So we're going to loop through here. We're going to cut that. Okay, cut that. We're calling back in here. We missed those other targets, so we're going to go to our second run. This is our second run here. We're going to say n at this point is equal to 8929. So we're saying that we're going to call upon this return method again of mystery, once again, mystery of n divided by 10, which will just cut off the one spot, so 892 is what we're called upon. And n plus 1 is just 8,930. Modulus 10, that's just going to give us 0, so we will actually not be doing anything. So we're cutting this off. We're looping through this again. Once again, our third run hits the spot here. So our third run, n is equal to 892. And what we want to do is we want to return 10 times the mystery of 892 divided by 10, which will just give us 89. I think you guys can see where this is going. Modulus, it gives us 3. We hit back here again because cut the 10 spot. I mean fourth run will give us this. N equals 89 at this point. We know that we want to return 10 times the mystery of At this point, we finally get into something interesting. Well, I mean, something more interesting than we have been getting into. We finally hit a base case. So 89 plus 1 modulus that is just going to give us 0. So at this point, we finally hit the mystery of n equals 8. Now at this point, we know that this is our 5th run through the recursive tracking. N equals 8 at this point, so we've hit here. We are going to be returning n plus 1 modulus 10, which is just 9. So we're returning that 9 for the mystery 8 here. So that just becomes 9, which ends up becoming 90. Did I get that right? Plus 1 modulus 10. Yeah, okay, 90. 90 is good. Okay, so then that 90 ends up becoming the solution for this. Actually equals mystery of 89. I'm sorry I didn't do this earlier. So we can replace 89 with 90 here. So this ends up becoming 903. And this ends up becoming, yeah, because of the recursive backtracking here, this is actually the mystery of the previous, which is 892. So we can replace 892 with 903. And 10 times 903 just gives us 930, which ends up becoming the mystery call of 8929. So this ends up becoming just 9030 times 10 plus 5, which gives us 90305. And that should be the final answer here, 90305 for the final. Now let's actually check that to the actual answer, see that we didn't screw up anything here. Okay, so we're going down, going down, going down. And the answer is 90305, and that just so happened to be what we had. Alright, that's just a little bit of mystery for recursive backtracking. Now, of course, you know, when you're running through this, when you run through the first and the second here, you should be able to see the pattern for the final, and you should also see a pattern here for the fourth. So I mean but this is just a basic this is just the basics of it, so I hope you guys enjoyed. Sorry for the long video. Feel free to skip forward through. Well, of course, I guess if you've reached the ending here, there's no point in skipping through, but see you guys in the next video.